Okay, so guys, we have a two types of routing protocol actually. So routing protocols has categorized in the two ways. One is we have a distance vector routing protocol, and another is we have a link state protocol. In that one, what happened in that one, the protocols has divided. So we have a RIP over there, we have a EHGRP over there, we have a IGRP over there, right? In this one, and link state we have a ISS protocol and OSPF over there. This two protocol has comes in the, so basically routing protocols has a two types. Okay, basically the routing protocol has a two types. One is the distance vector routing protocol, and one is the link state routing protocol. And in that distance vector, further they have categorized with the RIP, EHGRP, IGRP, and the link has further categorized with the ISN and OSPF. Now the question is that if you already have a, right, if you already have a distance vector, then why we have introduced the OSPF protocol? Why we have introduced the link state routing protocol? If the already we have a distance vector, then why we have introduced the link state routing protocol? The first question comes in the mind. Guys, a quick example I have. For example, a guy is sitting over there, right, in the network home, and this guy in network home wants to go to the Marathali to meet someone. So this guy has came from the Delhi, and this guy does not know anything about the Bangalore location. So this is the right now present network home, and his girlfriend is living in the Marathali location, okay, in the same Bangalore location. Okay, so what happened in this case, try to understand. Okay, so what this guy will do, they started this journey, they have a, they rent the scooty, right, they rent the scooty, and this guy does not have any knowledge of the map, no map knowledge. Okay, so what this guy will follow in the 90s 80, what happened in the not 90s, in the 90s 90s, what happened in this case, if the person that is living in the HSR layout right now, and this guy has came from the Delhi, they don't have any knowledge about the Bangalore location. The location source is SSR and destination is Marathali. Okay, they started their journey from the HSR. There is a board sign over there, and the board sign is saying that go straight, okay, 2 kilometers, and you will reach to the Agra, right? So what this guy will do, because on the board he's written that if you go now Marathali, right, if you want to go the Marathali, first you have to reach to the Agra, and to go to the Agra you have to go straight to the 2 kilometers. So once this person has to go to the street, and it will reaches to the Agra location. Once this guy reaches to the Agra location, what happened after the seeing the board on the Agra, because on the road what happened, we have a boards are there, right? On the highway what happened, we have a boards. So once this guy reaches to the Agra, not on the Agra, he's saying that take right, and go straight 5 kilometers, and you will reach to the Belandur location. So still the destination is Marathali, right? Still the destination is Marathali, and now this guy has reaches to the Belandur location. Now on the Belandur, what happened is the board is saying that take left and go 5 kilometers straight, and you will reach to the Marathali location. Now this person is going to take a left and go straight, and this guy now reaches to the Marathali location, and now this guy will go miss to this girl. This is how your distance vector works. In a distance vector routing protocol, what happened? Right now this guy is living in the HSR layout, right? Right now this guy is living in the HSR layout. They only have a knowledge about the Agra. Once this guy will reaches to the Agra, now they have a knowledge about the Belandur, right? What is the next location? It was Belandur, right? What was the next location? Whatever the location was there. So once this guy will reaches to this location, and now it will move it to this location. Now this guy has a complete knowledge about the this location. Once this guy reaches to this location, now this guy has a complete knowledge about the this location. So completely what happened, this is totally rely on the neighbor. This is totally rely on the neighbor, and this is totally rely on the neighbor. This is not a good thing. As per the routing protocol, router means what? Router, this is the ISP. ISPs are connected of router. There's lots of router are sitting in the ISP. And if you go look like this, if you follow this path, it is not a feasible solution. In the distance vector routing protocol, do you know what happened? In the distance vector routing protocol, R1 has a knowledge about R2. R2 has a knowledge about R3. R3 has a knowledge about the R4, right? R1 has a knowledge about the R2. R2 has a knowledge about the R1 and R3. R3 has a knowledge about the R4 and R3. But R1 does not have any knowledge about R3. They have a knowledge about route. I'm saying the detailed information. R1 does not have any knowledge, no detailed information about R3. R1 does not know what is the detailed information on R3. R1 does not have any idea about the R4. R1 only know about the R2. It is something like that. If R2 is going to inform if R2 is going to inform R1, hey R1, 4.0.0.0.0.0 is almost 90 kilometers away. You know what happened? R2 has to be assumed that, R1 has to be assumed that, okay, 4.0.0.0 is 90 kilometers. Because in the distance vector routing protocol, what happened? A router is totally relying, right? A router is totally relying on the neighboring router. A router is totally relying on the neighboring router. A router is totally relying on the neighboring router. But R1 does not have a complete information on R3 and R4. This is the problem is happening. In the distance vector, I'm not denying you can implement the distance vector in your company network where we have a small routers are there, 520, 20, 20, 30, 50 routers are there. But in the ISP network, we always give the preference to the link state protocol, always. Because a distance vector is not a scalable. If you have a huge amount of router in your network, distance vector is not a feasible solution, because in the distance vector, what happened, whatever the neighbor will give the information to me, I have to believe it. That is the meaning of routing by rumors. Whatever the information my neighbor is going to inform to me, I have to believe it. Remember the AD and FD concept, sorry, AD and RD concept, EHRP, advertised distance and reported distance. So if R2 is saying that, okay, if R2 is saying that R1, hey, 4.0.0.0 is 90 kilometers away, R1 has to be believe it. That is the AD and RD, advertised distance. That is my routing by rumor. Whatever the information my neighbor is going to tell me, I have to believe it. Same thing. This right now, HSR has the only knowledge about Agra, right? Agra has a knowledge of the Belandur. Belandur has a knowledge of the Marathali. They only know the hop by hop information. But if I'm seeing a complete map, no map. They don't have a detailed information about the network. If you're going to implement the router EHRP in this case, R1 has a knowledge about R2, but R1 does not have a knowledge about R5, a detailed information I'm talking about. R1 has a knowledge about R3, but R1 does not have a knowledge about R5. R1 has a knowledge about R4, but R1 does not have a detailed information on R5. R2 has a knowledge about R1 and R5, whatever the neighbors we have. R3 has a knowledge of R1 and R5, but R3 does not have a knowledge of R6. A complete information they don't know. So if R5 is going to inform to the R4, hey, R6 is 5 hops away, they have to believe it, right? Because my neighbor is informing. Is it the good 5 hops? It's a 1 hop away, right? But if R5 is going to inform to the R4, R4 has to believe it. This is the meaning of routing by rumors. Whatever the metric you will advertise it, I need to assume that. Okay, this is good. This is the problem is happening with the distance vector routing protocol. That's why we have introduced the link state protocol. And how the link state protocol will work. A simple example, a Google map. If I'm going to tell you, for example, this is the guy that is totally new in the Bangalore location, and right now they are positioned in the airport, and they want to go to a network home HSR layout. What happened? If they have a Google map, right? If they have a Google map, they will find the shortest path, because based on the Google map, this guy, the ABC, this guy has a complete knowledge about the city now. A Google map is a very good example of link state protocol, guys. In the link state protocol, what happened? If you're going to run the link state protocol in between this topology R1, R2, R3, and R4, R1 has a complete knowledge about R2, R4 as well as complete knowledge. They have a R1 is going to maintain a map, and in this map they know which one is a better path. R2 is better path, R3 is better path, even R5 is a better. Which path is better? They know the complete information about the R4. Every router, not the R1 even. R1 is going to maintain the complete routing, complete map information. R2 is going to maintain the complete map information. R5 is going to maintain the complete map information. Even R3 is going to maintain the complete map information. So link state protocol, you can compare with this thing is a Google map. And if you have a Google map and the person is ABC, it's totally new in the Bangalore, they can easily find how to reach to the network home. They will just see the Google map, and based on that, they will find the shortest path and they will reach to the network home. But in the distance vector routing protocol, what happened? They don't have a Google map. They don't know. They only know the neighboring routers. I'll show you this thing, how the OSPF is going to create the map of them. So OSPF is also a routing protocol that works on the IP. Okay, that has a protocol number will be 89. So whatever the OSPF packets we have, all this packet will be encapsulated with the IP. So this is the IP header, and under that we have a OSPF packet. OSPF stands for Open Shortest Path First. As the name suggests that it's a open means what? It is a IEEE standard. Where was EIGRP was a Cisco proprietary when it was introduced, but now it is a IEEE standard, right? Because in the 2013, the IEEE has Cisco has opened this guy, the protocol, the IEEE standard, right? In the 2013. But initially the OSPF, when the OSPF has came in the market, I think so it was came in the 90s, 88. I'm not sure. I think so 1988 or 1987. When the OSPF has came in the market, on that time it's the open standard protocol. And whatever the packets we have OSPF, all this packet will be encapsulated with the IP header. So it works on the layer 3. Like a EIGRP has a 88, right? Now, OSPF has a 3 version. Version 1, that is totally legacy now, and it was only introduced experimental purpose, right? Then version 2 has came. Version 2, I think so it's came in the 1994 nearby. I'm not sure. 1990, after the 1993, between the 1994 and 1995, version 2 has came. Now we are using this thing. and it is a default version. OSPF. Then we have a OSPF version 3 that you can, version 2 only support the IPv4, not IPv6. Whereas version 3, it is for the V6 as well as. Now, so EHRP is open standard. Can we use this different? Yeah, we can use it. The RFC has published in the 2016. So previously it was introduced by the Cisco system, and it was a provided protocol. Now it's open standard. In the 2013, it is converted in the open standard, but RFC has designed in the 16. Now, one more thing that I'm going to tell you guys. OSPF has a 3 version. I'm not denying it, right? OSPF version 0 was also there, right? I just inform you, version 0 was also there. Okay. But these two things, you cannot find the RFC of this one. Okay. You can find the RFC of this one. Maybe you find it, but I didn't see that RFC. I just check it somewhere. So version 0 was also came, but it was not so popular. Then it was introduced the version 1 because they have lots of issue with the version 0, right? Then it was introduced the version 1, but again the version was it's just a experimental purpose. That's it. And then the version 2 has came, and now the version 2 is it was the class 4, right? And the version 2 is a classless and class 4 both of them. They support the classless and class 4. Okay. So now the first of all, what is the meaning of link state protocol? So guys, let me tell you what happened. This my router number 1. Okay. This my router number 2. And there's a link between this guy interface 0/0 of physical media, and this is the R1, and this is the R2, and this is 0/0, and this is 0/0. Perfect, right? And this will be a 12.1 IP address. This will be a 12.2. Clear? Now, what is the meaning of link first of all? Link is what? Link is interface. Right now, this is the interface. This is the interface, this is the interface, this is the interface, and this is the interface. Right now, this is the interface. But once I'm going to enable the OSPF, right? Once I'm going to enable, once I'm going to put the OSPF on this guy, what happened? Now this interface will be converted into the link. Right now, previously what happened, there's no OSPF over there, right? And this was just an interface, normal interface, physical media. Either it can be a gig ethernet, either it can be a fast ethernet, serial link, anything. But once I'm going to put the OSPF guy over there, what happened? This interface will convert into the link. For example, if you have a R3 over there and this interface 0/1, right? I have enabled the OSPF. I have enabled the OSPF on this interface. So this interface is now convert into the link, but still this is a interface because I didn't enable any kind of OSPF over there. I didn't enable. So once you enable the OSPF on a particular interface, right? Once you're going to enable the OSPF on a particular interface, that interface will convert into the link itself. And your router will become the state. So after the enabling the OSPF on this router, right? After the enabling the OSPF on this router, once I put the command router OSPF, and after that I need to define the process ID. A 16-bit of number, you can use any number, right? And this number is a local to the router. It's a 16-bit of number, you can choose any number. Let me write on this thing. You can choose 1265535, right? And it is local to the router. Local to the router means what? If you remember that, if I'm going to run the EHGRP, on this case, if I'm going to put the AS number 1 over there, right? I have to put the AS number 1 on this guy as well as. If I'm going to put the AS number 1 over there, I have to put the AS number over there as well as, right? Then it will form the neighborship. For example, if you're going to put the AS number 2 over there, they won't form the neighborship. AS number mismatch is happening, right? But in this case, what happened doesn't matter, right? This is not a AS number. This is a process ID. And process ID is local to the router. Local to the router means what? I'm just going to put the router OSPF number 1 over this guy on a R1. On a R2, I can put the router OSPF number 2. Doesn't matter. They will form the neighborship. But it's not recommendation, right? It always see. It's just a understanding purpose. It is a local to the router, but it's not recommendation to use the different process ID. I'll tell you why later on classes, right? But it's not recommendation. So it's local to the router. You can use any process ID over there. I can use the process ID 1. Once I'm going to enable the router OSPF 1, this router is now converted into the state. Previously, what I told you that this is just an interface. Once I'm going to enable the OSPF on this interface is now converted into the link. And once I enable the OSPF on this router, this router will become the state. That is the meaning of link state. And protocol means, you know, a set of rules. Set of rules means what? If you're going to enable the OSPF on this guy, you have to enable the OSPF on this guy as well as. It's not like that you're going to enable the EHGRP between this guy. A protocol mismatch will happen, right? Set of rule means what? What is the rule of this training? You have to come 5:30, right? Then you can attend the batch, otherwise you can leave it. Rules means what is the protocol? Protocol means rules. Rules means what? If this person is know the English language, this should be learn the English, right? If they know the German, right? If they know the Japanese, can they communicate A and B? Of course not. They must know the same language, right? If you want to provide the communication between the PC A to the PC B, I need to know the English as well as. That's the meaning of protocol. So if I'm going to enable OSPF on this guy, I have to enable the OSPF on this side. That's the meaning of protocol. Clear? Now, let me tell you how to enable the OSPF. The first command, I just put the router, put the question mark. You will have a huge option. You can enable the EHGRP, IGRP, BGP, RIP, ISS protocol, OSPF. Just put the question mark, right? You will get the huge information. But I'm interested to run the OSPF protocol over there. I simply say that OSPF. Then put the question mark. You will have a 16-bit of process ID. You can take any process ID. It's totally up to you. I can say that router OSPF 1. And once you put the enter over there, what happened? Now you will move in the routing protocol mode. So this was the config mode. And in the config mode, I have defined this command. Once I put the router OSPF number 1, I'll move to the router mode. After putting this command, what happened? Try to understand. Once I'm going to put this command on a router number 1, what router number 1 is going to do, it first look up. Do we have any active interface? If we have, then OSPF will start. Otherwise, it prompt the error. For example, if the router does not have any IP addresses, right, you cannot enable the OSPF. But you can enable the EAG-IP. Let me show you this thing. Conflict terminal. I just put the question. So, do we have any active interface right now? No. Router OSPF number 1. Read this message. You see that timeline. OSPF process, OSPF. This is the OSPF protocol that I'm going to use. The 4 is the severity label, and this is the description, right? I cannot start the OSPF because I don't have any active interface. Now the question is that why do we need an active interface over there? Because to select the route ID. To select the router ID, as we know that router is a 32-bit number that is representation in the x.x.x.x format or IP address format. So you cannot start your OSPF without router ID. So right now I don't have any kind of interface over there. So what he's saying that I need to first configure the IP addresses, right? Then I can enable the OSPF. For example, I said interface loopback number 1, IP address will be. Okay, let's define the interface 0/0. IP address will be. Now I put the router OSPF number 1. Okay. Router OSPF number 1. Now they will not prompt any kind of error over there. I don't have any error because now we have an active interface and I can select the ID. Same thing, if you have a look over there, I can do in the interface loopback number 2, IP address will be. Interface loopback number 3. How many active interface right now we have? 3. Already we have assigned for this guy as a OSPF number 1, right? Clear? Now, router OSPF number 2, no error. Router OSPF number 3, no error. But router OSPF number 4, error is coming. Because now I have assigned for this guy. I also assigned for this guy, also assigned for this guy. A 3 process ID we have OSPF 1, 2, and 3. For 3, I have 3 separate router ID. For each process ID, we need to have a separate individual router ID. OSPF process cannot start it, right? Because I don't have any active interface for the OSPF process 4. If you have a look over there right now, Do show IP OSPF include ID. Perfect, right? अब ये मत पूछना why the OSPF process 2 is going to take the 2.1 and why the OSPF process 3 is going to take the 1.1. Please, already we have discussed this thing in the EHRP. We cannot start the OSPF process 4. Can we see that? Do we have any OSPF process 4? No, I don't only have OSPF 3, 2, 1 because I don't have a router ID for this guy. And as I told you that router ID is what? It's just a 32-bit number, right? Eight, 32. So what is the election criteria of the router ID? First, it will give the preference to the manually. Second, it will give the preference to the highest loopback. And third, it will give the preference to the highest physical interface. So if you have a 3 process ID, right? OSPF number 1, OSPF number 2, OSPF number 3. What happened? Let me do one thing. Let me make it more simple. I have a 3 interface right now. I have 0/0. Then loopback number 2, loopback number 3. 3 interface. This is the 3 active interface we have right now. This 3 active interface we have right now. And once I'm going to put the command router OSPF number 1. As I put the command router OSPF number 1, it's a 16-bit of number process ID. It will choose the router ID. So router ID for this guy will be automatically right. Because I always give the preference to the highest loopback. Then if I'm going to say router OSPF number 2, it will go for the RID number. If I'm in the router OSPF number 3, then it will give the preference to the 1. Can I start the router OSPF number 4? Of course, we should have an arrow, right? We cannot start the OSPF 4. But as I told you that router ID is what? It's just a identification of router, right? It is. That's it. It's just an identification of the router. How we can identify the router in this logical domain. This is the one classroom, and this is the one logical domain. How we can identify a router. This is the router, this is the router, this is the router, this is the router. How we can identify the router? Which one is the R1, which one is the R2, which one is the R3, which one is the R4? To put the ID, right? So router ID was just an identification of the router. Do I need to have any kind of active IP address over there? No. I don't need to have any kind of active IP address, just identification, right? So if you read this message now again, what is saying that? Once I put the router OSPF process 4, he's saying that OSPF process not ID cannot pick, right? Why is it cannot pick? Because I don't have an active interface. So he's also saying that please configure manually. Route ID. Now this will be started. Do so IP OSPF include ID. It's good. Right now, I still have a free interface. 2 minutes. So hope so, guys. This thing is clear to all of you. So router ID is not a IP address you have to present in the routing table or the IP address table. It's just an identification. You can do anything. It's totally up to you. Doesn't matter is present or not. Clear? Now, second thing. Right now, still this command right now. Router OSPF number 1. So once I put this command, what happened? The OSPF process will be started on this router, or simply we can say that this command will enable so how many things will happen till now by using this command? By using this command, you can enable the OSPF process on the router. Second thing, the router will select the router ID. Third thing, once you put this command, what happened? Now the OSPF router is going to create a one table. For example, how many router OSPF of there? 3, right? So now on a single router, we have created this 3 process ID. This is a single router. On a single router, we put this command, right? Do you know what happened? You will have a separate table for the OSPF number 1, separate table for the OSPF number 2, and separate table for the OSPF number 3. This table is known as a LSDB table. That is stand for the link state database. So if you have a multiple, if you have a 10 process ID, 10 LSDB table you will have, and for each LSDB table you will have a separate algorithm. Guys, I'm still present on this command right now, router OSPF number 1. I'm just explaining what is the meaning of this command. So what this guy will do, for we have a one separate SPF algorithm for this person, separate SPF algorithm for this person, and separate SPF algorithm for this person. Now tell me one thing, what I told you that OSPF process ID, it's a local to the router, right? If you run the router number 1 and router number 2, process ID 1 and process ID 2, and on R3 we have process ID 3. So this interface belongs from the process ID number 2, and this interface belongs from the process ID number 3, right? Because on R2 we have run the two process. This process for this interface and this process for this interface. You can run multiple processes. How many CPU utilization will be high on this guy router? On this router, what is the CPU utilization of this guy? Of course, high, right? Local to the router, it's not meaning that you can run the multiple process ID. Local to the router, it's not meaning that you can run the multiple process ID. Yeah, you can run if you have a requirement. But in this case, what happened? You are just increasing the CPU utilization of the router. At the same time, wastage of memory. Because its process ID is going to have a separate database table. So this database table for the OSPF number 1, This data was table for the OSPF number 2, and this data was table for the OSPF number 3. So guys, make sure that whenever you are going to enable the OSPF, don't enable the extra features over there. If you're going to enable the extra features, you will have a separate LSDB table. At the same time, for each LSDB separate table, you will have a separate SPF algorithm. Right? Now, once I put the command router OSPF number 1, now you will move in the router config mode. And now here you can say that network dual or 0. And then you can define the wildcard mask. Right? And after that, you need to define the area. Question comes in the mind, what is area? And why do we need of area in the OSPF? I don't have this concept in the EIGRP and RIP protocol, even not in the BGP. Why the area comes in the picture in the link state protocol? Quick example I have. One big school over there, right? In this school, what happened? There's a 1,000 students over there. And to manage the 1,000 students, how many people are there? Single people. Tell me what is the load that happen on this guy? Load will be increased. If I'm going to tell this guy, this is the principal of this school, and this principal is saying you have to manage this 1,000 people, the load will be increased. The load will be increased on this person, right? They cannot do the better work. The performance of this person, right? The performance of this person will be degraded. So what we can do over there, we simply say that, okay, 1,000 students, let me divide some blocks. I said that this block 2, 3, 4, 5, sorry, 6, 7, 8, 9, 10, and each block is going to contain the 100, 100, 100, 100, 100, 100. Now your 1,000 students are clear. And for each classroom, I'm going to have a one separate person. Each classroom is going to have a one separate person that is going to maintain the classroom. So as compared to the load on this person, what I did, I just divide. And if I'm going to divide the workload, what happened? Your performance will be increased. Same thing I'm going to do in the OSPF configuration. Why we have introduced the area concept? Area is nothing but we just need to divide your network into the small portion. In this case, what happened? You can easily troubleshoot. You can easily manage, and your performance will be high. That is the benefit of the area having in the OSPF, not the EHGRP. So OSPF is just going to divide your network into the logical domain. OSPF is going to divide your network area is a 32-bit number. You can define decimal, like this. For example, area 0, area 0, 8, 8, 8, 8. So what happened? For example, this is a network of there. What OSPF is going to do is not going to increase the load, because as I told you that OSPF has a complete map topology, right? So R1 has a complete knowledge of R2, R3, R4, R5, R6, R8, whatever the router. Whatever the router in your network, R1 has a great knowledge, good knowledge, everything. That will be not good for the R1. What I can do over there, I can simply say that, okay, let me divide the areas. This is a logical area. We can create another logical area, and we can create another logical area. And to define this logical area, we have some identifier, and that identifier is known as a area ID. The identifier for this person is a area 1, area 2, or area 3. So what is areas? Area is a group of router. And as I told you that it's a logical domain. Logical means you can expand anywhere, doesn't matter. For example, R1 is sitting over there, Delhi. You can put the R2 in the Bangalore location. No need to have any physical things, guys. You can expand your things. It's totally up to you. That's the benefit of the logical things, right? So in this case, what happened? Now R1 has a complete knowledge. Previously, what happened? R1 has a complete knowledge about R3, R7, R6, R8. Now R1 has a complete knowledge about own area information. Only own. R1 has a complete knowledge of R2, R5, sorry, R4 and R5. R3 has a complete knowledge of R6. R7 has a complete knowledge of R8. They have only own knowledge. Like that, we can say that simply. Delhi. Delhi की बहुत याद आ रही है. Mumbai. Patna. Delhi has a own complete map, own map. Mumbai have a own map, and Patna has a own map. So whatever the person, these are the R1, R2, R3, R5. These are the person that is sitting in the Delhi. So they know the own information. This guy know the own information on Mumbai. This guy know the own information about the Patna. This is something like that. Your area is works in your network. It's just going to reduce the overhead on your router. Area is just going to create a logical domain between the routers. It's a group of routers that is within the logical domain, and that has an identifier is known as a area ID. You can take any area ID in the 32-bit number. But area 0 is reserved for backbone area. It must be present in your network. B dot area 0. You cannot provide inter area communication. We can say that B dot area 0, you can't provide communication between area 1 and area 2. It should be present. Area 0 is a backbone means what? A person has a backbone, right? A person has a backbone. Without backbone, they cannot even stand. So without backbone area, the OSPF cannot understand. You cannot design your network. You cannot design your network without the area 0. It must be there. For example, R1. Okay. So user are sitting behind the R3, user are sitting behind the R1, right? And we can make a one logical domain. So logical domain till this point, logical domain till this point, and this logical domain name has a area 1, and this is a logical area 2. Do we have any area 0 over there? No. And if you don't have any area 0, or we can say that backbone area, you cannot provide inter area communication. So between the PC number 1, host 1 cannot communicate with the host 2. No possible. Yeah, whatever the user sitting in the area number 2, for example, this is the user that's sitting in the area number 2, they can communicate with this person, they can communicate with this person. But whatever the user that is present in the area 1, they cannot provide the communication between this guy. Inter area communication not possible. You must have to area 0, backbone area. Simply the backbone is what? A person has a backbone. Without backbone, you cannot stand, right? So area 0 should be present in your network. That provide the inter area communication. How? Look like this. R1, R2, R3, R4. Let's do one thing. Area 1, area 0, and area 2. Now whatever the user sitting behind the R1, whatever the user sitting behind the R4, they can communicate. They can communicate now. He said, hi. Hi. Let's date. They can date anyone. Simply. But area 0 should be present, right? Without area 0, you cannot provide the inter area. This is the inter area right now. This is inter area. This is inter area. Communication within the own area, right? If the user intra means what? Own area. Done. So we have done with this command auto OSPF number 1. Okay, and that is what is the use of this command? Enable the OSPF process ID, select the router ID. It will create a one database table, and on that database table, it is going to run the SPF algorithm. For each process ID, we have a separate database table. We have area 0 is complete. Backbone area. Now area is further classified. Area is further classified, and it has a backbone area that I told you that it should be present. Then we have a normal area. Then we have a stub area and a necessary. area itself has classified in the 4 ways. You can define in the 4 ways. You can have a backbone, you can have a normal, stub, and NSC. As I told you that it's a area is a logical domain. It will create a logical domain, and that is a beneficial for your network. So it will break your large network, right? It's break your large network. The benefit will happen. You can improve the performance. और कुछ बचा आइडिया में? We'll see that what is the meaning of backbone normal. Everything we'll see that. Don't worry. Backbone area 0 will be there. Backbone area. Okay. And normal area you can take any number from 1 to 32 bit. You can take any number. Stop area and NSC, these are the special type of area. We'll see that later, right? Okay, और कुछ है? एक रुको. Backbone area, decimal number. Done. Now you can put the area. We can define in the decimal format or dotted decimal format. It's totally up to you. Once I put this command on the router number 1, router number 2 also require the same command, right? We can also advertise this look like this network area, single interface area 0.0.0. Doesn't matter. So you can enable one side as a decimal format, another side dotted decimal format, no issue. Once I'm going to enable the OSPF on this 2 router, what happened? They will form the neighborship, right? They will form the neighborship. As I told you that this process ID is going to create a one database table, and this process ID is going to create a one database table. So R1 has a own database table, R2 has a own database table, and this database table name is LSDB. Done. So now what happened? R1 is going to share the own information to the R2. R1 is going to share the own information to R2. Now R1 is going to share the link information. R1 is going to share the link here. Link is what? Interface. What is the information about the interface? The information about the interface is your IP address. So what happened now? R1 is going to share the own link information to the R2, and R2 is going to share the own link information to the R1. And this link information is known as a LSA. This link information is known as a LSA. LSA is what? LSA stands for link state advertisement. As I told you, link means what? Interface. State means what? A router. Advertisement was share the information. So R1 is going to share the own information to the R2. R2 is going to share the own information to R1. And this link information is known as a LSA, link state advertisement. So once both the router, right? Once both the router is going to advertise the own link information, what happened? Now this link information, right? This is the LSA. This link information is known as LSA. Will be stored in the LSDB table. So now I am going to store this information and I'm going to store this information. So LSDB is what? It's a collection of LSA. LSA is nothing but it's just an information about your interface, like your route, right? 1.0.0.0.0, what is a route for you route, right? For the EHRP, for this is the route. For the BGP, this is the NRI. EHRP, it's the route. BGP, it's NRI. But for the OSPF, it is known as a LSA. Right? For the EHRP, it is route. For the BGP, it's NRI. For the OSPF, it's known as LSA. So router is not advertising a route. In this OSPF case, what happened? Router will not advertise the route. It advertised the LSA information. Router advertise the LSA information. And what is LSA information? The information about your link, and that will be stored in the LSDB table. And as I told you that you are going to learn this information as a dynamic way, right? Of course, we have a timer for this guy. We'll see that whatever the timer we have, don't worry. So this is how the LSA, this command is going to let you know about this thing. So this is a few commands, right? How to enable the OSPF. Router OSPF number 1, that is going to enable the OSPF on the router. At the same time, this link will be this interface will be converted into the link, and this router will be converted into the state. Same time, after that, they will find the own identifier, router ID, and they will create a one database table. And on that database table, I'm going to run the one algorithm. That is the SPIP. This guy is present on this guy, and this guy present on the. Once your LSDB table has created from the LSDB table, right? From the LSDB table, now the R1 is going to deploy your routing table. Try to understand what happened in your LSDB table, right? In your LSDB table, you will have a best path information and second best path information. Best path information, second best path information, whatever the best part, right? In your LSDB table, you will have a complete information. This LSDB table is your map. It's a map of your router, right? And this map is going to contain all the information. And on this map, what happened? This is how, right? This is just assume that this is the cell phone, right? On this cell phone, whatever, this user is going to perform the Google map. Same thing. This guy name is SPF algorithm, and what this guy SPF algorithm will do, this is the map LSDB table. It is going to find which one is the best route. So whatever the best route we have, this best route will be copied in the routing table after running the SPF algorithm. SPF algorithm will be run on the LSDB table, and the best path will be stored in the routing table. Non-best path always present in the LSDB table. This is the best path. So router always, whenever the router will receive this information, whenever the router will receive the information on the 0/0 interface, whenever it will put this information in the LSDB, and from the LSDB it will go to the routing table. This is how your OSPF works. SPF algorithm will be run on the LSDB. LSDB is what? It's a collection of LSA. I'll show you this thing. Don't worry how the best path and second best path is calculated. Don't worry about that. I'll just giving you the overview right now. OSPF, what is actually OSPF and how this thing is works. This is the one command. This is the one way that you can enable the OSPF on a router. Second way, I'll let you know. Second way, you can enable the OSPF. This is the global configuration mode. Second way, you can enable the OSPF on a per interface basis. First, just go in the interface 0/0 IP. IP means again, I'm going to enable for the IP product, sorry, IPv4. Then OSPF, mention the process ID, mention the area. Simple command. So maybe you have a question, law, in this case, will the router will select the route ID? Of course, 100%. Once I'm going to put the IP OSPF 1, it will select the route ID. Right? So if you don't have a IP addresses, then again it will prompt the error. So guys, what I told you that, let me recap again one thing. Router OSPF, put the question mark, select the protocol, select the process ID, 16-bit of number 1. Once you put this command, OSPF process will be enabled and they will select the router ID. After that, each OS process ID, each process ID is going to create the separate database table, and on that database table we have a separate SPF algorithm. Let's have a look. Do show IP protocol summary. How many processes we have? 4. Then you will have a 4 database table. Do so. I'll explain you each and every command. Don't worry. Show IP OSPF database. One database table for this guy. Questions, guys? Anyone has a question still now? You can ask me.
So OSPF is the only protocol can be enabled in the interface level or any other protocol?
रुक जाओ यार, मैंने प्रैक्टिकल अभी जितना मुझे पता है, रुको, रेप नहीं कर सकते, ये जरपी नहीं कर सकते, बीजीपी तो कर ही नहीं सकते, OSPF यू कैन डू दैट। आईसीएस का प्रैक्टिकल मैंने बहुत पहले किया था यार, ऑलमोस्ट 2 साल पहले, मुझे याद नहीं आ रहा है। लेट मी 1 मिनट, लेट मी रिकैप दैट। आईसीएस यू कैन इनेबल ISS. No, you can't. ISS. No, you can only enable the OSPF. You can enable the ISS. You can't. Single OSPF is there. Anyone has any questions in the basic configuration of the OSPF? What is the any issue in the any command line on the router OSPF number 1 and this network statement? And again, the same network statement use. So I no need to explain what is the use of network statement. Okay, so hope so this command line is clear to all of you guys, right? So I know same Zoom. Prabhu, same Zoom link is there. Switching best. So this was the experimental version 1, and the version 2 we are using right now. So the first RFC has came in the version 2. It was the RFC 1247, right? And after that it has come with the 2328 RFC. ये वाला पढ़ना चाहो तो मैं दे सकता हूँ. If you want to read the RFC, I can give you. It's a 200, almost 250 pages of this one. You can read. If you want, you can read it. Okay, and then so what is the benefit of the having the area? So area is something like that. You can reduce the protocol impact on the CPU and the memory. That's why we have introduced the area concept over there, and it is a fully classless behavior, right? That support the VLSM as well as route lookup in an efficient manner. It can perform the equal cost load balancing as well as that every routing protocol is performing. It's not new things over there. Okay, we'll discuss the multicast address tomorrow, not today, because this is a different multicast happening over there. They have a support the authentication. So the good thing about the OSPF, they will support the 2 types of authentication. You can go for the text format, or you can go for the MD5. It's not a 2, actually it's the 3, right? Authentication is 3. One is going to depend on null authentication. Second number is going to depend on the text authentication, and third is going to depend on the MD5. Okay, by default it's set to the null. Null means no authentication. By default, if you see the OSPF hello packet, it will show the null authentication. So state I'm not discussing right now. Any else information? No hello protocol. Not interested. Not interested. Yeah, I want to discuss this thing. Transit and stop route. See, you have a 2 types of route in your network, right? You have a 2 types of route in your network. In your OSPF network, 2 types of route is defined. One is the transit network, and one is the stop network. Transit means what? a router that carry data plane traffic and that provide the connectivity system. It is considered for example, this is my stop network, 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 right? These are my transit network, because this link is going to carry your data traffic, this link is going to carry your data traffic, this link is going to carry your data traffic, but this link never carry your data traffic, this link never carry, this link never carry, this link never carry, this link just process your data traffic. This is the stub, like last host. So your OSPF, the good thing about the OSPF, it is able to consider it, which one is a transit and which one is a stub. That is not possible in the any other protocol. I'll show you in the Wireshark as well as in the CLI and the database table. The loop back, right? The loop back is also always treated like a stub network, always. It's always treated like a stub network because they cannot forward the data traffic. The another benefit of the OSPF, do you know one thing? Let me tell you. Let me show you over there. If I'm going to run the router EGRP over there, right? I'm going to need, let me create the one loop back over the interface loop back number 1. Perfect. Right. Then R2 interface 0/0. Sorry. Yeah. Name has completed, right? Which network I have created? 10.1.1/8, right? Tell me how many hosts we have. /24 host is there, right? As I told you that one loop back, is treated like a one broadcast domain, is it? And in this one loop back, how many hosts are there? 24. But actually, how many hosts are present? Single. And if you check the R1 routing table, /8, what R1 is assuming that? R1 is assuming, oh, there's a lots of network behind the, sorry, there's a lots of user that is sitting in the 10.0.0/8. What R1 is assuming, there's a lots of users are sitting in the this network, because /8 means what? 24 host, sorry, 24-bit host. Can you imagine 24-bit host? What R1 is assuming that there's this amount of hosts are sitting in this network. That is the problem in the EHGRP. What EHGRP is going to do? EHGRP is going to treat like a loopback as a complete network, but actually it's not like that. In this case, what happened? What a neighboring router is going to assume that, oh, there's a lots of users are sitting in this network. But if you come to the R2 router, R2 is saying that this is a single host, and in this broadcast domain, there's a single host is present. But when R2 is going to advertise this route to the R1, it is going to advertise a complete network information. complete subnet information, complete network. That is not a good thing, because in this case what happened, again performance will be degraded. As compared to process the 24-bit, 24 host bit, I'm going to process it over there. What OSPF is going to do, if you just run the OSPF in this case, router OSPF number 1, sorry, I'll create another loop back. Same /8 is there, right? But you know, if you check the routing table R1, do so IP root /32. EHRP is advertising the same route with the /8, but OSPF is advertising the same route with the /32, because OSPF is know how to identify the person. Is this route is a loopback? Is this route is a transit? That's the meaning of transit and stub host over there. So as compared to this one and this one, how R1 can assume that this route? R1 can assume, okay, this is the single host. This is single host. What this guy is going to assume? This is this range of host. This is the EHRP and this is the OSPF. So this is the great achievement, right? This is a great performance that will improve the great performance of the OSPF. चले तो ये दो नेटवर्क आप कल पढ़ते हैं यार, थक गया मैं. Any questions? Anup, पूछ तू यार, कोई क्वेश्चन.
/24 means 256 hosts, no sir?
Sorry?
/24 means 256 available hosts will get, no sir?
/24 host means how many prefix? Sorry, how many IP address is there?
Available IP address is 256.
How? पहला बात कि 255 तक ही IP, 256 आता ही नहीं है. First thing, only 256 IP, 255 is IP, 256 never come. Can anyone? Class A means what? /24 host bit. Class B means what? /16 bit host bit. And class C means what? /8 is a host bit. Class C means 255 host.
Okay. Sir, and last Thursday's video, can you share once again?
तूने डाउनलोड क्यों नहीं किया?